Hello guys, it is Afronix again. So our last tutorial we dealt with how to use the visual designer of Proteus 8.12. Today I have an interesting message. Two message. One is that I want to thank you for I'm talking about you. I'm saying yes, you the one watching this video. Thank you for watching Afronix videos. So, and also thank you for subscribing to Afronix. If you haven't subscribed yet, kindly smash that red button and also click on the bell so that when a new video is being updated you will get the alert. Okay, so that when a new video is being uploaded you will get the alert. Okay, and the second thing is that we are going to look at the line follower, just like you see from the beginning. That is the introduction of the video, so we are going to do that. So with that, so let us go straight. In this case we are going to open samples. Okay, we are going to use a sample. Now you say open samples. Now you see these are the samples that you can use. They are like samples in Proteus 8.12, so you can see. All right, then we have this other one. This is for the visual. You can check the category. We have for Arduino, and then we have for Raspberry Pi, but today we are going to look at visual designer for Arduino. So click on this Arduino. When you click, here is the samples you can take from Arduino. We have different samples. We have virtual total. So today we are going to look at the last at the bottom, which is the visual designer for Arduino Zumo Line Follower. We are going to look at a line follower. Okay, so if you click on it, say opened down here, click say open, you give it some time, then this nice looking platform will look. You see there is no code, it's just a drag and drop. Okay, let me zoom it out so that we can see clearly. Okay, here is the setup. Now let us now look at the schematic capture. Here is the Arduino board, and then here is the Zumo board. Okay, the Zumo Robot board. Okay, now the setup loop, you have to, first of all, when you sit in your car, before ever you start, you know that you already know the maximum speed of this car, and the zero error, I mean the car is not yet moving, so the error is at 0 at that time. Okay, so that's why it has been initialized, and then they put error 0, maximum speed is equals to 255. Now you may be wondering how comes 255, how it's 255. So let us do a comment about this. Okay, click. Now the 255, we know that we are dealing with digital component, okay, electronics, and in this case we deal with binary form because computers can understand zeros and ones, right? That is binary form. So in that case, when you put a binary number, okay, now for the maximum for 8-bit, because the Arduino board will be taking 8-bit, it is an 8-bit microcontroller. So if it is 8-bit, okay, now for you to find the maximum, number it can reach, okay, using 8-bit, is going to give you 2 raised to the power n minus 1. And what is n? Our n is, this one supposed to be capital N. Okay, so what is our n? Our n is equals to number of bits Okay, so in that case this would be, now you see, because of n is equals to 8. So then, which means that the maximum number it will reach will now give you 2 raised to the power 8 minus 1, which will give you 2 raised to the power 8 is 256 minus 1, which is equals to 255. So that will be, so meaning it will start counting. So it will start counting from 0 to 255. Okay, so this is the maximum it will reach, and this would be the least it will go. Maximum, this is the maximum and this is the least. Okay, hope that is clear. So that is what we have explained here clearly. Okay, so I hope we all get that clear at this point. So next, now here it is now the loop, and in this loop we know that loop will be running continuously. Okay, you say now to get the position of the line, how can you get what happened here? Before now you want to start a car. Now let us look at a line follower. Now let us take a look at the line follower. You know, this line follower, it has sensors. It is running on this black line, meaning it has to trace the black line and follow on the black line. And tracing the black line, it has sensors. Okay, these sensors, they are called IR sensor, infrared sensors. Okay, and these infrared sensors, they send, it is like the sensor that we are having remote and the TV. You click, you have the receiver and the transmitter. Okay, so that is the sensor that is sensing this black line. Okay, now before you start, you have to first of all align this car onto the on the line. So in putting it, it has to look at the line position, right? So that's why we are starting straight away with the line position here. So now to get the line position, then we have to go to line sensor. How can you get the line sensor? You come to Z1 line sensor here. In this line sensor, you click the drop down, but we have two. Either you read the value or you take the line position, but we are looking for the line position, so you just have to drag this and drop it just like that one. Okay, but we are not using this one. So okay, so now you have your line position. We are done with the line position. Next, you go for the error. Okay, because you have to determine the error that is available. Now, in getting that error, our error is equals to line position. This line position minus 256. This line position minus 2500. Now you may be asking yourself, how comes this 2500 comes about? Okay, so this is how far. To calculate the error is how far we are away from the center of the line. So this line, that from the how far we are away from the center of the dark line, so the position, it corresponds to 2500. That's why we came across, we have this 2500 and okay, next we go to the speed difference. After the error, we go to the speed difference, and the speed difference will now be equals to error all upon error divided by 4 plus 6 times 10 raised to the 4 plus 6 times error minus last error. We know last error was 0, right? So this error we calculated at the top. Now you may be wondering how comes this 4 and 6 comes about and how this formula comes about. So to get it, it is by using the proportional and derivative PID terms. Okay, PID terms. So in this case, how comes the 4 comes about? 4, this 4, it is 1 upon 4. That is the proportionality constant, okay, of PID terms. The the proportionality constant is 1 upon 4, and the 6 is the derivative constant. So that's why this 4 and 6 came about. Okay, now we have the last error will then be equals to 0, and then we now here is now to check the position of the speed. Okay, we check the position of the speed. Now how can you check the position of the speed? Let me show you some. Now let us get this right. Okay, now we see we have straight, left, sharp, left. Okay, that could be right, left. Now here, now if you are turning facing your computer right now, here will be the right wheel, and then here will be the left wheel. Okay, now when it goes straight, when it is going straight, it means that this and this, they have to be moving together. When they are moving together, then the vehicle will be moving straight, right? Now what about if you want to take a left turn? If you are taking a left turn, then it means that the left wheel need to go to 0 and this one need to be going, so it will spin this way and then curve. If you want to take a U-turn, when this one is pushing backward and then this one is pushing forward, it just take a U-turn like that. That is what we call sharp left turn. Similarly for right, this is the right wheel, it has to go to 0 and this one needs to be pushing so that the car will turn this way. So sharp right also is the same. So that is what is being happening here to look at. So we want it to be spinning for it to look for the black line. So in spinning for it to get the black line, like if the car is out of the black line, then it has to be spinning in one direction. So in this direction, we want it to be spinning in the left side direction. It will be spinning in that direction to find the line. So that's why I give here max speed plus the difference speed, and then for the right, say max speed minus, so this one will be reduce, and then this one, so that it will be spinning to find the black line. Immediately it senses the black line, then it arrange itself. Okay, we come to this subroutine. This is a subroutine. A subroutine means another function that could be called into this program. So we can find here is the subroutine. At this, you drag it like this, so it is the subroutine. So in doing that subroutine, we created another sheet that would be called here. So you just have to right click, say new sheet. When you new sheet, this new sheet will appear, but we don't want that to happen. And when that new sheet appear, you can just take, drag and drop. Okay, but we don't want this sheet, so we just click and say remove sheet. Yes, remove. Now we have the subroutine. In this subroutine, that is what will be called in this function, and the name of the subroutine, the event is being named as bound speeds. Okay, that is the name of it. Okay, now let us look at, it has given decision box, and these are the decision box. The decision box is here. Just click and then you put your decision there, and the decision here, let me show you something. Now in the decision making is like this. Now it's going to start, it's going to say, did you sense the black line? Right? You say, is it that all of the sensors, are they the one that sense the black line? If it is yes, then it has to reverse. Okay, the reverse will do. So both motors, same speed and same direction, so they will move together. The motors, this wheel now will move together. That is a forward movement. Okay, but if that doesn't happen, you say no. If it doesn't happen, then it means that one of the two has sensed it. So is it that one, that is it the left that has sensed it? If it is yes, then it's going to be a left turn. Okay, now what if the left didn't sense it and it is the right that sense it? If it is yes, then it's going to take a right turn. Then it has to take a right turn. Then it has to take a right turn. Okay, then if nothing like that will happen, then it will still go forward, moving forward. All right, so that is the phenomenon that will be taking place here. Now this is now, it is called the drive. So this one, it will now be driving the wheel that will be going left, the direction it will be forward, and the speed will be left speed. Left speed has been calculated here, and the right, the same thing for the right, and it ends. Now it is time for us to compile the code. This what has been made here. So you compile it by clicking on this build project, you build it. Now it has successfully been completed. That means it is compiled successfully. Now it is time for us to run this program. If you click on this run, now look at our Zumo, okay, line follower. It is following the line steadily, okay. See, now let me take it out. See, it will be spinning in the left direction, just like how we programmed it. It will be spinning for it to sense the line. You see, these black are the ones sensing the line. Immediately it senses the line, you see it turn to green. So immediately hence it is on the line, it will be moving in the direction it is sensing. See, now this is a track, okay. This is from a sample. Now what if you want to make your own track yourself? I mean, I want to make my own track. What should I do? So it's very simple. Let us close this. Now you come to the schematic capture, double click on this one, or right click and click on edit. Now in edit, you have to put the obstacle map, and in making this map, it has to be in PNG form. So how do you do it? Either you go online and find this track, right? You can go online and find the track. But for me, I said, okay, let me make my own, let me customize my own track. So what I did, I opened PowerPoint, okay? This is PowerPoint 2016. So I need a blank, slide, okay? Now come to this slide. I want to customize my own line. I want to design it my own way. So how can I achieve that? Okay, I come to insert. From insert, you go to shapes. Then from shapes, now you have to look at these lines. You can choose the line of your choice, but I want to use this one, which is free form, okay? Free form line. I click on it, okay, so I can say go this way, come this way, then connect it to this other line. So now you have this form, and when you have this form, you right click and you go to fill in, okay? Fill in, you just have to, if you click on the drop down, you just say no fill in, okay? Or you can come to this format. From the format, you go to fill in, then you say no fill in. So you have this, and then you right click and then you go to format shapes down here. From format shapes, this nice thing will appear. So we want to look at the line, okay? If you click on the line like this, if you click on that line, and then this drop down will appear. Let me expand. The drop down will appear, and then you have the width of the line, okay? Let me bring this at the center here. Okay, now you have the width of the line. It is 1 point, okay, pt. So you just have to increase the width. Let me take it to 10. 10. Okay, that is 10 pt. Okay, now you click on it, and then you know this line, this track is 10, right? It is, you know, this track is, we know this track is blue, so we can change the color to black because it's going to sense black. So we have our line, right? Now how can you save this in PNG form? You go to file, come to save as, come to this PC, you can find any area you want it to be installed. Now let me say map, let me say Zumo map. Okay, Zumo map. Now you click on this drop down and then make sure it is picture form. Look at it, PNG. Okay, click on it. See, now this question will be asked. You say all slide or just this one? I want only that slide, so only this slide. So it has been saved already. Now I have to go back to my purchase. Double click here, and then you come to this one where you want it to be. So here it is, where these are the samples it came with the package, but I've made my own customized one. So I will just click on quick access. It means I just save it. So look at it here, Zumo map, click on it, open, and then say okay. Now if I run, look at my map. See how nice it looks. See how beautiful it looks. It is going smoothly. It is going smoothly. Now if you have your Arduino board installed, connected, make sure that you click stop, and then you click on this one, let us say here, and then you find the COM where it's connected. I didn't connect my Arduino today, so if you have your Arduino, you just make sure that the COM will be where the Arduino is connected. Then you click on it, okay, then you hit on this one to upload, and this code will be uploading to the Arduino board. When you fix it to your Zumo, you are good to go. Alright guys, this is what I have for you today. Thank you for watching this video.